We are in the building. It's coming up. Okay. So now here's what we're going to do today. For those of you guys that are new to me, my name is Professor TK the Chemist, and I go live Monday through Thursday, 12:15 p.m. Eastern Standard Time. And since we're in summer school, I'm also going live as well in the evening time at 7 p.m. I try to do General Chemistry 1 and 2. Sometimes it's a task to do both because, I just never know who's going to join my live and based on what they need to know. So what you guys will see is my schedule. All right. So I do go live Monday through Thursday, 12:15 p.m. So if you're catching me right now, you're in for a special treat because we're going to learn some chemistry. Now, these are some of the topics that some of the students told me they wanted to learn yesterday. And I said, oh, yes, I got you. Just hold tight and I got you covered. I do know that some students are going to be doing what? They're going to be in summer school starting next week. So let me go ahead and switch my screen so that everyone can see it, okay? And for those of you all that are going to go back and watch this on YouTube, you will be able to see all of this as well. So in terms of this worksheet, hello, Shabazz, how are you doing, love? So what we're going to do, I am going to go through these practice problems because I know that so many students struggle with this during chemistry. And if you don't know how to round, that will play a role in what we do. Now, I got to figure out how to get this tree thing off. Okay. Because I don't want it on there anymore. And y'all, I'll be trying to play with these little features. And yeah. Let me see if I can go to background and say none. Okay. Okay, hey T, how you doing? Yes, 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 yes. So T, yes, I am doing this to go live Monday through Thursday. So I'll be doing this every day. When I start summer camp, I won't be able to go live during the daytime at 12, but I will be doing it at night. So I'm still going to be doing it live every night, even now. But on those 2 weeks that I'm doing summer camps during the day, I will resume that schedule, the daytime schedule, after summer camp. But yes, 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 yes. I'm so glad that you are here. What chemistry are you taking again, T? Help remind me of that. Thank you, Hillary. And y'all, let me hold on for a second. I'm really trying to make sure I get rid of these little this little background. Hey, Specificity, how did you do this semester? You gotta tell me. Okay, T, you said you're retaking 1 and 2 and the lab. Wait a minute, wait a minute, wait a minute. Are you taking, oh, okay, specifically, you got your final exam on Thursday. I'm rooting for you. You got this. You got this. You got this. Just answer the questions that you know, and then you're gonna do well. Look, I already know that. I already know you are. Now, T Scott, you said you took them in 2018 and now you're a post-bac. Okay. So are you taking 1 and 2 this summer? Like, how is that set up? Because I know in some schools, like part 1 is generally like 8 weeks. And so how would you be able to take part 2? Unless it's a collab class. 4 weeks. Oh my gosh. 4 weeks. Honey, you can do it, but I just want you to binge watch my stuff if you need any additional help. Okay, I want you to binge watch my stuff. Okay, because I know it's going to be a lot of information you're going to have to retain for that particular topic for chemistry. It's a lot. It's doable. It is doable. So that's the pace I'm going to take this class. So every week that I go live, I'm going to be doing something different. And I'm going to be posting a schedule sometime today so you guys will know when I hop on what subjects we're going to go over. So for this particular one right here, yesterday we talked about significant digits and we did a couple of practice problems. So let me just recap that for you guys that were not here with me yesterday. Okay. So when it comes to significant digits and significant numbers, let me zoom in a little so you all can see that. Okay. So when it comes to significant digits, You have to keep in mind that numbers 1 through 9 are all significant, yes. Statement number 2, zeros that are sandwiched in between other significant digits, that means the zeros are also significant. Statement number 3, trailing zeros in a number are significant only if there's a decimal present. And statement number 4, zeros that are at the very beginning, whose only function is a placeholder, doesn't count unless there's a decimal present. That's right, Kayla. And there's a ring, aka the ring. That's right. Thank you, Kayla, honey. Thank you for that reminder. That's right. That ring means that if there's a decimal present, when there are zeros there, that's the only way the zeros will count. But let me tell you about that ring being present, though. Okay. So, like my friend in here, T, Miss T said, listen, I took chemistry in 2018. So, in other words, we don't want to know about your past, but when you get to the present, that 7 and that 9, that's what matters. Okay. That's what's going to count towards your future. So, in other words, zeros don't count when they're at the very beginning. Their sole function is a placeholder. However, if you have a zero that comes after the 9, for instance, like in this example here, then those zeros count because guess what? There's a ring present, aka the decimal. And when the decimal is there, okay, that means only the 3, the 8, and the 0 count. Same thing in this example here, 3,800. The 0 in front doesn't count, but the zeros after that significant digit does. And then we practiced a couple of these examples, and we went through and talked about the rules for addition and subtraction. And what we talked about in reference to that is that whenever you are doing an addition or subtraction problem, you have to bear in mind, or keep in mind rather, that your numbers are rounded off to the least amount of digits after the decimal place. So that means if you're adding numbers or subtracting numbers, and then you see what your calculator gives you, you only round off based on what the least amount of digits after the decimal, according to what you have. So if you have 0, so for instance, in 152, there isn't a decimal here. You have 2 significant digits after the decimal in this value, and over here, you have 1. So when you calculate this answer, your calculator is going to give you 158.11, but you have to round off to just simply 158 because you're going to go with the least amount of digits after the decimal. Now, when it comes to multiplying and dividing, what do you have to keep in mind? In this case, same numbers, but now you got to look at the entire digit, the entire number. So whereas before we were looking at what's after the decimal, when it comes to multiplication and division, you look at the entire number. Okay, so in all 3 of these digits, we have different numbers of significant digits here, but the one with the least amount, which is 2, tells us that's how our answer should be rounded off. So if your calculator gives you 1,403.568, that means I only need 2 of those numbers. And in this case, that 4 is the second digit or the second number that you need. So the 0 to the right of that says round down or keep it as is. So you end up with the answer being 1,400, okay, instead of 1,403. Okay, so again, those are the things that we discussed yesterday. Now, today, we're going to continue our discussion when it comes to rounding. We're just going to do a couple of these rounding problems, and then I'm going to go to scientific notation, because scientific notation is very, very important for students to know and do. Why? Because scientific notation, sometimes when you have big numbers like Avogadro's number, you don't want to have to write that number out. Okay, you just want to keep the number in scientific notation. And for many of you all that are going into the science field, STEM field, and you're dealing with bacterial cells that are very, 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 very small, you may not want to write out in the lab, in your lab notebook, 0. all these bazillion zeros, let's say 274. Instead, you may want to say 2.74 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9 to the negative 9th power. So in chemistry, we are teaching you guys tricks and tips, or tips and tricks, in order to make your life easier when it comes to writing out these numbers, okay? Now, in this first value here, you're going to round these numbers to one significant figure. And we're going to do a few of these because we're going to transition our information to scientific notation. So just to kind of recap, if I told you to round 896 to one significant digit, you always highlight the number that you need in terms of the value. Like if I only need one and I see 86 right here, that means the 6 tells the 8 to round up to a 9. But you cannot just leave that as a 9. You have to say 90. You still have to account for the other decimal places, or the other place values rather, in your number, okay? So 86 becomes 90 when you're rounding up. And if you think like money, like these green trees around my little border here, that'll help you remember that. I can't figure out how to get it off. I got it on, but now I don't know how to get it off. So y'all gonna have to work with me with this little border. Now, if you take a look at number 4, where you have 328, okay, so 328 means that I only need one significant digit. Notice that I put a little dot above the 3. Now, remember, even though you have a 2 and an 8, and I only need one significant digit, you're going to keep the 3 as is, but you're going to remove the 2 and the 8 and replace them with zeros. And so that's how we end up with 300 for number 4. That's right, Kayla. Very good. Okay, so let's take a look at number 7. Number 7 is another good example. Number 7. Okay, you have 1723, 1723. So what do you have to do? Again, I only need one of those significant digits. I'm highlighting that one significant digit, but I look to the right of that number. The right of that number right here is a 7. That 7 tells that 1 to raise up to a 2. But remember, you can't forget about the other 3 digits. That's right, Kayla. It becomes 2,000. 2,000. That's right, Mihawk. Hey, Mihawk, how you doing today? That's right. It becomes 2,000. Now, we also did this where we had 2 significant. I'm doing well, thank you. Thank you so much for joining. Now, if you take a look at this next example right here, suppose you had those same numbers and I told you to round the numbers off to 2 significant digits. Okay, well, here's the deal. We're going to do number 1, okay? And I'm going to show you again. Oops, I'm sorry, y'all can't see that. There we go. We're going to do number 1, okay? And again, you've got 869. And because it said to round off to 2 significant digits, I'm highlighting the first 2 numbers. Now, you're going to look to the right of that number, to the second number, and notice that that 9 is telling that 6 to go up. Now, again, you can't forget about this third digit here. So when you round the 6 up to a 7, you're going to still keep the 8 as is. That's right, Kayla. It becomes 870. Okay, very good. Very good. Let's take a look at number 5. Number 5. So here again, and number 5 is 693, okay? 693. So again, I only need 2 of those numbers. But remember, you cannot forget about that third digit right there. So I know that the 3 tells that 9 to stay put, and the 3 gets replaced with a 0. That's right. Hey, Carolina, that's right. 690 is correct. Mihawk, 690 is correct. All right. Let's look at number 10. Number 10. Suppose in number 10, they told you again, you have 11.70. Okay, we only need 2 of those numbers. Now, you all tell me, what does that answer become? Okay, Kayla, you said 12.00. Remember the ring. If you got 12.00 and Carolina's saying 12.00, let's talk about it. So you only need these 2 digits, right? But here's the thank you, Mihawk. That 7 does tell that 1 to go up to a 12, yes. But because that decimal is there, that decimal means what y'all do afterwards doesn't count. So you're going to only have 12 and not 12.00. Because remember, Kayla, like you told me at the very beginning, 12.00 means you have 4 significant digits in this particular case. 4 significant figures. So if you put the decimal with those zeros, that's going to increase. There you go. There you go. There you go. Okay. Let's do number 9. Number 9. You've got 8.921. 8.921. Okay. So again, we only need 2 of these digits right here. So what are we going to get? That's correct, Kayla. 8.9. Very good, very good, very good. That's right, Chasney. Chasney. All right, very good, very good. Now, what I'm going to do, because you guys got this down packed, let's go ahead and take a look now at our discussion that we're going to actually get into today with scientific notation. Now, again, let me give you all some tips and tricks on how to remember this for scientific notation, okay? Let me switch over my screen. And I'm going to kind of express to you guys why when it comes to significant numbers, okay, scientific notation, all those things matter. But let me give you all some tips and tricks on how to remember this, okay? So if I give you a number such as, let's say the number is 7.21 times 10 to the negative 4th power. Okay, with a number like that, when it's a negative sign, that means you're going to move your decimal to the left. To the left, 4 times, okay? So, in other words, 4 times to the left is going to give me this answer in decimal form. So in scientific notation, when the number is negative, you're going to move it to the left, okay? That number of times. Now, I'm going to show you all a quick trick, though. Instead of having to remember, like moving your decimal that many times, just add that many zeros. So I've got 4 zeros, and then 721. Now, of course, you're going to put the decimal in between the first 2 zeros, and then keep it moving. But in case some of you guys are like, TK, can you show me another way, like the way that I used to do it back in the day? Oh, I got you. You're going to still do the same thing. 1, 2, 3, 4. Right there. You're going to put a 0 in front. And where there's those little lumps, you're going to put the zeros right there. And you still end up with the same number or the same value. Okay? You still end up with 0.000721. So whether you simply put the number of zeros you see based on the exponent first and then the number, or you move your decimal that number of times to the left, either way will work. Now, if you have a positive number though, okay, let me show you that same number, but this time a positive value, 7.21 times 10 to the positive 4. So I was getting ready to write, well, let me do it this way, positive 4, okay? So in this particular case, you're actually moving your decimals. When the sign is positive, you're going to move your decimal that number of times to the right. That's right, Carolina, that's right, to the right. So you've got 7.21. I'm going to move it 4 times to the right. So that's 1, 2, 3, 4. And you end up with 72100. Now, I know, thank you, Kayla, that is correct. That's the correct answer. Thank you, Haley, for the follow. Now, here's the deal, though. Some of you guys are going to probably ask, well, should we put the decimal at the end of the number? I'm going to say no. If you do, that means your number of significant digits will increase. Right now, we have 3 significant digits. But if you were to put the decimal at the very end right here, that's going to give you 5 significant digits. So in this case, you want to not put the decimal there, but just know that you moved it. It's an invisible decimal, so to speak. You always want to go by the base that you see here. The 7.21 has 3 significant digits. So you want to keep that same energy and write out your 3 significant digits just accordingly the same way. So 7.21 times 10 to the 4th power will still give you 72,100, and you still have your 3 significant digits without putting the decimal on the very end. Now, I say that because I'm going to now show you all some practice problems here. And for those of you all that just joined me today, I go live Monday through Thursday, 12:15 p.m. Eastern Standard Time, and also in the evening time, 7 p.m. Eastern Standard Time. If you want to learn more about what I do, you can also go on my YouTube channel and you all can get this actual playback, the entire playback in its form. Okay. So if you all would like to do that, by all means, you can do that. Okay. Matter of fact, you guys can see here that I am live, I believe. Let me see. Yep. I don't know why it's pausing, but yeah, let me reboot. And so y'all can see that. Yep. See, there it is right there. Okay. Now, let me go ahead and screen share onto the new page of what we're going to go through. And it deals with some scientific notation problems. Okay. So let me move this out the way. With scientific notation. So here we go. So right here, when it comes to scientific notation, what you guys have to remember is that scientific notation is quite simple as long as you work with the rules that I said. Hey, Andy. Yeah, we just did significant figures. Matter of fact, you can actually go back and watch my live from yesterday on my YouTube channel, and you can get the full replay on significant figures. But I will also still keep that while we're doing this part. I'll still continue to state those points as well during this live. Oh, you're welcome. You are so welcome. All right. So now let me zoom this screen out a little so you all can see the whole thing. There we go. All right. So right here, it says write numbers in scientific notation. So if you are given a number like this, okay, let me get my little annotation pen. There we go. All right. So if you are given a number such as this, 157, whoops, 000, okay? And I told you to put this answer in scientific notation. Here's what you have to do. You're going to simply move your decimal 1, 2, 3, 4, 5 places to the left. Now, again, hear me out. Whenever you are writing a decimal form number in scientific notation, you must always move the decimal between the first 2 significant digits, okay? So in other words, hey, Belle, how you doing, honey? How you doing? Hey, Yana. You have to always remember to put it in between the first 2 significant digits when the number is big, such as this. Now, again, we moved it 1, 2, 3, 4, and 5. So guess what? Our exponent is going to be positive to the 5th power. Okay. What you eating for lunch? So you're going to put 1.57, the base number that you originally had. And also remember too, guys, you had 3 significant digits. And because you had 3 significant digits, that means you only need 3 significant digits when you write it in exponential form. Okay? So if, on the other hand, you have a negative number, or no, I shouldn't say a negative number. Let's say that the number is small, where you have 0.000837. Okay, like this example right here. Here's what you're going to do. You see how the numbers, the zeros, are at the very beginning of the number? Okay, pizza. Yummy yum. Lena said, does General Kim use Avogadro's number? Yes, it does. And that's why we're going over Avogadro's number in terms of exponents. Matter of fact, here's Avogadro's number right here. But who wants to write that big number? That's why we put it in scientific notation. Now, what we're going to do, we're going to actually take this number here, that 0.000837. We're going to do what? We can move our decimal, but let's count the number of zeros. We have 1, 2, 3, and 4. So guess what? My exponent is going to be times 10 to the negative fourth power. That base here, the 837, we're going to write that as 8.37. Now, for those of you all that said, you know what, I see that, but can you write that number by showing me how you move the decimal? I got you. Here we go. You're going to take your decimal point right here and move it 1, 2, 3, and 4, right there between the 8 and the 3. And you still have 4 decimal places, okay, or 4 spaces that you went down to give your 4 decimal to your exponent. Okay. Now, let's do a couple of problems. Now, a lot of times when you all are doing this in your chemistry stuff and you're like, oh my gosh, they're saying too much. Well, here's the deal. I like to show the simplest ways of doing problems, but I know sometimes your book has to explain more in detail. Some of you guys may be visual learners, where you can see it and you can impart it, but some of you all are kinesthetic like me, where you got to actually draw it out and write it out. So we're going to do just that. Okay. So for number 1, let me zoom in a little so y'all can see the numbers a little bit bigger. Or right here, we're going to do number 2. Right there. Okay, so right here, you've got this big number, and we got to put it in scientific notation. I already know I have 2 significant digits, okay? So I don't need to worry about adding those zeros on the very end. So I'm just going to say 5.3 times 10. Now, I already know that this exponent is going to be positive because this is a very large number. And you're probably wondering, well, how do you know that? Listen, if y'all had these numbers in your banking account, which some of y'all may do, you know that's a big number. 530,000, okay? So again, if you think like money, hey, you can easily identify with these numbers, okay? So in this particular case right here, I'm going to move my decimal 1, 2, 3, 4, 5. So my exponent is to the 5th power, okay? So that's 5.3 times 10 to the 5th power. Now, many folks, though, are on the struggle bus. Okay, this economy is like, what? But I still know I'm going to put 5.3 as my base number times 10 to the negative. Now, you're probably saying, well, how do you know that? Well, look at all these zeros at the very beginning. If your checking account looked like that, you know that's a very small number, okay? That's not even a penny in your account. Thank you, Kayla. -4. And how do you know -4? Count those zeros. 1, 2, 3, and 4. And that is correct. Times 10 to the -4th power. But again, for those of you all that want to see, like, how do we know to count that and move those decimals? Let me show you. All you're going to do is just say 1, 2, 3, 4, right in between the 5 and the 3. And that's how you can also get -4. Okay, now let's do another example because I stay with the examples. Because when you do your homework, oftentimes teachers, well, I don't do this, but some teachers only give you one example and say, now do the rest. But you didn't have enough to really do it with. You know what I'm saying? So I'm going to actually give you all plenty of examples that you can work with. Okay, so here we go. We've got this small number right here, 0.000000092. Now, there are 7 zeros. So all I'm going to do is say 9.2 times 10 to the negative 7th power grams. Okay? That's it. Now, again, if you want to see how do we get negative 7 again, you can either 1, count the zeros, or 2, you can just move your decimal place. 1, 2, 3, 4, 5, 6, 7. You always go between the first 2 significant numbers, okay? And that's it. That's it. Now, in a case like this, like letter D, where the number is very big, it's a large number, just go ahead and put 6. I only have one significant digit there, okay? And what am I going to do? I'm going to count over 1, 2, 3, 4, 5, 6, 7, 8, 9. Kayla, you own it, girl. You are on it. So 6 times 10 to the 9th. Instead of saying 6.0, because remember, if you put 6.0, that's going to give you 2 significant digits. So instead, it's just simply 6. Okay, simply 6 for that number right there. 6 times 10 to the 9th. Same thing with this. Okay, with this next number, we've got a lot of zeros. Okay, a lot for letter E. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to put 1.26 times 10 to the 10th power milligrams. Okay. And that's it. That's how you do decimal form to scientific notation. Decimal form to scientific notation. Now, suppose we want to do the reverse, which is how we started this in the very beginning. You got 1.87 times 10 to the negative 5th power. Remember, just add those zeros there. The negative 5th power means 5 zeros. And then the base, 187. Okay, that's it. But when you get to 5.99 for letter B times 10 to the 7th power, what you would have to do, again, I'm going to write this off to the side over here. 5.99 times 10 to the 7th means I'm going to take my decimal and move it 7 times to the right. Remember, a positive number like this means to move it that number of times to the right. To go from, and remember, because that's a big number, you want to move it to the right to expand the number. So 7 times, take your decimal, 1, 2, 3, 4, 5, 6, 7. Don't put the decimal on the end, but just know that that's where you're going to stop, okay? Fill in those lumps with zeros. And then we're going to write this in, 599. And I have 1, 2, 3, 4, 5 zeros. There we go, right there, okay? 599,000,000 milliliters. Yes, hey, Tabby. Yes, converting units. Yes, yes, yes. We will be doing that actually tomorrow. Yep, we're going to do that tomorrow. All right. Yes, so make sure if you're not following me, make sure you follow me, turn your notifications on, so that way you'll remember to come back, to come to my session. All right, so this next one, let's see, Kayla is on it. 9001. Yes, you are correct. So let's see how we got that. It was 9.001 times 10 to the 3rd power. Again, we're going to move our decimal to the right. 1, 2, 3 times. So that's how we ended up with 9,001 milligram. Go, Kayla. Go, Kayla. All right. 6.98 times 10 to the 5th power for letter D. Let's do that one over here. Okay. So again, it was 6.98 times 10 to the 5th power. So all we're going to do is do what? Move that decimal 5 times to the right. 1, 2, 3, 4, 5. Fill in those lumps with zeros, and you end up with 698,000 grams. Okay. And y'all, you know, letter E is simple, right? Just count those zeros. You got 5 of them. 1, 2, 3, 4, 5. And then put the 444 right there, kilograms. But your decimal goes right in between the first two zeros. Okay? 0.0000444 kilograms. All right. Now, let me see. I forgot your name. I'm going to go back through the comments. Andy. Andy, if you're still with me, we're going to now do some sig figs again as a reminder of how to keep that in your forefront. Okay? So right here, you've got, again, the sig fig rules. We've already discussed those. So I'm just going to, again, do some quick ones, some quick reviews. This is like your flash report, okay, so to speak. So you've got 525 milliliters. So whatever you see in parentheses, okay, parentheses, that's what you're going to round your numbers to, okay? So each of these are different, okay? Each of these examples are different. So in the first one, it says round 525 milliliters to one significant digit. So that should become what? Y'all tell me. Y'all put it in the chat. What you think? Okay, Kayla said 500. Let's see. That's correct, though. Yep, that's correct. 500 milliliters. All right, letter B. 7,527. Round that to 3 significant digits or significant figures. Remember what I told you about, guys, before. Good job, Tabby. Good job. 7530. Very good. Okay. And the next one, 0.04512. We only need 2 of those numbers. 2 of those numbers. What y'all think? Good job, Mika, as well. All right, so what y'all think for y'all thinking about it for letter C? Woohoo! That's right, Mihawk. That's right. 0.045. Remember, we only needed 2 of those. The 1 and the 2 goes out the door. We don't need those. And that 5 stays put. So, because remember, if you round down, then you just change that whole number and you still got 2 significant digits. If you say 0.0040, Kayla. Okay. And the next one, letter D. We only need 3 significant figures here. 3. Okay, let's see. Tabby got 0.000677. You are correct. Very good, Mihawk. That's correct as well. 0.000677. And how do you know that? Because remember, these are your 3 sig figs right here, but this 6 tells this 6 to go up. So you have to round up. That's correct. That is correct. And again, we're putting those units there because, you know, chemistry teachers love to see units. Units tells you what you're working with. And then the last one, letter E, round that to 4 significant digits. What you got right there? What would your answer be for this one? That's right. The number stays as is. Good job, Kayla. That's right. Okay. Now, what we're going to do. Oh, I need to charge my computer. That's what we need to do right there. There we go. What we're going to do now with the scientific notation, okay, I'm going to show you guys how to add numbers with scientific notations, okay? So you've got to still remember the rule though, okay? You still have to remember the rule in terms of adding and subtracting. Remember, that doesn't change, okay? So we'll do one of each before I come off because we got about 8 minutes. So what I'm going to do is we'll do letter B, and I'm just going to use my calculator on the live so you all can see me plug the numbers in. Okay, so we'll do letter B with adding and subtracting. Okay, with adding and subtracting. And we'll also do, let's see here, let me get a good one. We'll do C and E. Okay, C and E, and then we'll do multiplication and division. So C and E. Okay, C and E. All right. So letter C. You've got, well, I thought I said B. Well, I changed it. C and E. Yes, C and E, C and E, C and E. All right, so letter C. You've got 7.88 times 10 to the fourth power minus 1.55 times 10 to the fourth power. Here's something that you need to keep in mind. When you are subtracting, okay, or adding, you're going to still have 3 numbers as your base in terms of whatever you write in exponent form, okay? So that's not going to change. If you would have had 7.8 and 1.55, then you would only have 2 numbers in terms of your decimal, okay? Just a little tip and a little FYI. So let me plug this in for you guys. 7.88 times 10 to the fourth power, okay, minus 1.55 times 10 to the fourth power. And we get 63,300, okay? 63,300. But if I told you my answer must be in scientific notation, because most chemistry teachers will make you do the extra work like me, you're going to have to, again, go 1, 2, 3, and 4. Your answer, okay, will become 6.33 times 10 to the fourth power. Okay? 6.33 times 10 to the fourth power. So even though your calculator gave you, in mole, put the units there, mole. Even though the calculator gave you the answer in decimal form, suppose your teacher says, put it in scientific notation. This would be what you would have to do, okay? So decimal form, you still have the correct number of significant digits, which is 3. So 63,300 still gives you 3 significant digits. But if I say, y'all, I want you to put your answer in scientific notation, you have to move your decimal and make sure that you write it accordingly. Okay, let's do the next one, letter E. Letter E. You've got 4.72 times 10 to the negative fifth power, okay, minus 4.66 times 10 to the negative fifth power equals, now, on my calculator, and I know those of y'all on YouTube can't see me, but on my calculator, I got 6. Wait, let me do that again. I want to make sure I didn't hit the wrong thing. Looking at 2 things. 4.72 times 10 to the negative fifth power plus 4.66 times 10 to the negative fifth power. Yeah, see, I knew I wrote something in wrong. Yeah, I wrote it wrong, but this is the answer. 9.38 times 10 to the negative fifth power. 9.38 times 10 to the negative fifth power milligrams. Okay. That is your answer right there. Okay, Kayla said, "Well, this work should be going to be posted under the YouTube video." Now, I don't know how to post links like that, but like I said, I'm gonna make it. I'm gonna have to probably put this on my actual website, and you can just download it from there. But yeah, make sure you DM me, or I will click the link in my bio, and it'll take you straight to my website. The worksheet isn't there now, but I can email it to you also. Yes, I can email it to you also. And it also comes to the answer key. Some of the answers are wrong also because they did not keep the same energy with significant digits or in scientific notation. So you'll notice that some of the answers may be a little off. And I probably should have to notate which ones they are, but yeah. So yes, guys, and oh, let's do one real quick with multiplication and division, okay? Multiplication and division. So let's do letter D and letter F, okay? Letter D and letter F. So in letter D, you've got 2.68 times 10 to the fifth power, okay? So here it is again. Let me show you guys on the calculator, okay? 2.68 times 10 to the fifth power times, notice how mine automatically puts it in decimal form, times 4.11 times 10 to the negative power. Okay, I'm gonna write the entire number on the screen, 11014.8. Okay, here's the deal. I want the answer in scientific notation. So you know what you got to do, right? You've got to move your decimal 1, 2, 3, 4, 4 places to the left. Okay. So that gives you, and remember, you only need 3 of those numbers because you still got to write in decimal form what you have as the base. Okay. So you're going to write 1.10 times 10 to the, again, 1, 2, 3, 4th power, okay? Centimeters squared. You're welcome, Kayla. All right. Because remember, when it comes to rounding and multiplying and dividing, you still have to have the correct number of significant digits based on the entire number, okay? Letter E. Letter E. Let me see if we got one that has different. Oh, let me switch that up, guys. Let me do letter H because there's 2 different units. Not unit. Well, yeah, 2 different units, yes, but also 2 different numbers of significant digits. So I'm going to do letter H for you guys really quickly before we head off of here, okay? So for letter H, you've got 6.79 times 10 to the negative fifth power, and you've got 1.7 times 10 to the second power. Now, I already know that the units are going to be kilograms per cubic centimeters. This, by the way, is a density unit value, okay? I already know, too, that my final answer, if I've got 3 significant digits on the top and I've got 2 significant digits on the bottom, my final answer is going to have 2 significant digits as well, okay? FYI, FYI. So let's go ahead and plug this in. 6.79 times 10 to the negative fifth power divided by 1.7 times 10 to the second. So you get 3.994 times 10 to the negative seventh power. Okay, so again, I'm going to write all that out so we can come up with our final answer. 3.994 times 10 to the negative seventh power. Now, you're probably wondering, How did we get a negative out of that? Thank you, Mr. Wynn. Thank you. What you would have to do, okay, let me show you guys this real quick, okay? Anytime you have an exponent on the bottom and on the top, if I bring the one that's on the bottom to the top, and I bring the 2 to the top, you're going to say minus. So -5, -2. Two minuses give you a -7. You're basically adding the numbers and putting the exponent there. Okay? That's just another little tip. Now, but aside from that, our final answer should have 2 significant digits. And why do we say 2? Because look, the least amount of digits is what we need to go by. So I put a little line above that 9. That 9 to the right of that 9 tells that one to go up. So you're actually rounding this off to 4.0 times 10 to the -7th kilograms per cubic centimeters. Okay? That is your final answer there. 4.0 times 10 to the -7th kilograms per cubic centimeters. You have to remember that when you're doing homework in many college campuses where the homework software is grading you, they're going to mark 3.994 wrong. But what they will give you credit for is 4.0 times 10 to the -7th power. Because you have to use the correct number of significant digits. Okay. So these are just some examples of, going over scientific notation, significant digits, and the rules, rounding, and all that good stuff. So tomorrow, what we're going to do, we're going to go through the metric system so I can show you guys how to convert, let's say, a kilogram to a gram, or a gram to a microgram, liters to milliliters, and so forth. So we're going to get into that tomorrow. And again, this replay will be available to you guys on YouTube. So you guys can always go back over there and pick them up. Oh, you're welcome, Joy. Appreciate you. Okay, so if you guys have any questions, make sure you all comment on my last video. If there's anything that you want to see during the summertime, I will be doing summertime school chemistry until the end of June. And then July, we will take a break and start back up again in August. July, I will be posting like videos of experiments. I'm going to be doing experiments anyway, but I'm actually going to be doing a lot of different things on my page. Just make sure that you guys continue to follow and support, and tell a friend to tell a friend. And thank you, Tabby. You're welcome. And that's funny that your name is Tabby, because that's what my people used to try to call me, back in the day, Tabby, because of my first name. Used to call me Tabby for short. So yeah, just make sure you guys tell a friend to tell a friend that we're live every day, Monday through Thursday, 12:15 Eastern Standard Time. Okay, so you guys have a wonderful